Samir is ready. Okay. Hi, Samir.
Hi.
Samir.
Hi.
Okay. Let me introduce this. I am very happy to introduce this wonderful Samir Kumar. He is a member of AIA, NOMA, and principal of the Techne. Am I pronounced properly? Techne? Techne. And also founder. With over 20 years of experience as an architect and a facade specialist, Samuel has distinguished himself as an emergent leader at the nexus of architectural design, engineering, fabrication, and the material and process innovation. Through critical balancing of the craft, climate, and comfort, he creates sustainable and timeless solutions to complex design problems in the pursuit of a humanist vision of architecture. Through a continuous engagement with academia, spanning over 15 years, Samir has brought his passion for the comprehensive, complete design study to the graduate student at the Princeton University, the University of Pennsylvania, and the Pratt Institute. His experience designing building enclosures is founded upon a diverse and extensive career working with firms like FTL. I'm going to have some pronounced problem in here. Heintes, KPF, and the Shop, where he has successfully practiced in numerous prominent projects across the world. While no need more explanation, all the credentials that you may be able to say. Let us have Samuel to get a floor.
Thank you so much. I'm going to start sharing my screen. I hope you can all see it. Thank you so much for that wonderful introduction. I had forgotten what my introduction was, so I actually included a few slides about myself, which I'll now be able to jump through very quickly. So I am, as JJ just put it, I'm an architect, an academic, and a facade specialist. I originally am from India. I studied in India as well as at Penn in Philadelphia, where I graduated back in 2001, and I have been in New York ever since. I have been, sorry, this was incorrect. Yes, I have been, sorry, as it was already mentioned, my career as an architect has spanned multiple different locations, and some of the work that I'm going to show you here today is the work that I did with Shop Architects in my previous incarnation. I also have been teaching since 2007, and I now also teach at Spitzer School of Architecture here in New York City, and then I am a facade specialist, and I have been quite actively involved with the industry, with multiple agencies, and helping provide engagement across industry and design communities. And during this time, I have been very fortunate. I have had a great luck in being able to work on fantastic projects all over the world, and I have been able to travel to all these places and familiarize myself with both the industry and design communities. And earlier this year, I founded Techne, which is a building enclosure design practice. It is a facade consulting practice, and we really specialize in high performance, fully custom facades, and we're based in New York City. I actually want to start with the word Techne, which is the name of my company, and it is also very close to my heart because of what it means. It is an ancient Greek word which means acquiring knowledge by doing, or it is loosely now translated as craft with a deep understanding, so that craft starts to become art. But more importantly, Techne is the root of the word both the words architecture and technology, meaning that that it is in a way central to both of these ideas, and it therefore represents sort of my entire ethos of where I have gained experience practicing over the years. Following all of that, today I want to talk a little bit about the process of innovation within the world of craft and materials, and I want to take a slightly looser interpretation of the theme here, which is tools, but at the same time, every aspect of our activity as we work and solve problems, we use everything we have as tools in our hands. I want to specifically focus on two experimental, slightly non-architectural project works that I was fortunate to be a part of, and I was able to lead while I was at Shop Architects. And in both cases, there was a close participation between the design team that was based here in New York and the fabrication that was happening through significant industry players, NBK Terracotta based in Germany on one hand, and Boston Valley Terracotta based in Buffalo, New York on the other hand. And we will look at how whatever we as designers imagine, as it finds its way to getting materialized, it gets richer. Of course, terracotta as a material is not new to us. Not only is the material a very, very old and ancient material, but it is also widely used in building facades these days. And these are two of the projects that I have been very closely involved with. One in New York City, which is almost complete now. Some of you may recognize it. The others is Hudson site in Detroit, which is under construction right now. And both of these projects use terracotta on their facades on the towers. And both of these, this is the 111 West 57th Street, and these are some close-up views of the built facade, and it is showing you how the terracotta tiles, they are of changing geometry and they create these ripples on the facade. But this was, why this does it and how this is achieved is sort of another conversation. But the important thing is that all of this is achieved through extruded terracotta, right? So the most common way of using terracotta in architecture today is through an extrusion process. You can see the dies on one side, you can see how extrusions look on the other side. And for this project, for the 57th Street project, we took these terracotta pieces and then we incorporated other hardware within it to enable it to be mounted to aluminum facade panels. And that is what basically brought us to being able to put terracotta as high up as 1,400 feet. Which is the height of this tower, which is quite high, one of the tallest towers with terracotta on it. Similarly, the Detroit project, which is still under construction. So what the images you see here are renderings. They also use extruded terracotta as a part of the facade. And these are some images of the mock-up and some images from the fabrication shop. You can see on the upper right corner, the extruded terracotta piece and the hardware that goes into holding it in place. So this is where we start, right? We as architects, as facade designer, I was very familiar with terracotta as a material. When in 2017, we were invited by the Milan Design Week by Fuori Salone to come and participate in this significant exhibition that they conduct during the design week. And this was a sort of a combination, Shop invited NBK to participate because we were working a lot with terracotta and we wanted to try something interesting and new with NBK. We offered to NBK that we would like to find a new expression to terracotta without, while using their existing methods of fabrication, without changing anything. We'd still like to find a new appearance of terracotta. And they got excited. And, Interni is the name of the company that organizes Fuori Salone. A little bit about this event where we were invited, they have a long history of inviting very prominent architectural practices and design practices to come and produce temporary installations, something that stands up for 2 weeks or 3 weeks, and hundreds of thousands of people come and view it. So this is really just meant for a display and display of your design capability or production capability, whatever it is. So it is very much an exhibition piece. And the location is right in the heart of Milan, in the State University, the Statale building. And this building itself, interestingly, is extremely ornamental, all of it decorated with terracotta. And so it sort of set up a point of departure for us. When we started out, we were like, okay, on one hand, we have this building and its gorgeous ornamentation. And on the other hand, we have this extremely modern extruded terracotta expression that we're also familiar with. How do we bridge this gap between something that was highly ornate and archaic and something that is very industrialized and very repetitive and therefore, in a way, slightly banal? And our, since we were limited by the process of extruding it, our investigation started with the idea of, okay, what do we do with an extrusion that has not yet been done before? And one of the obvious things that we happened upon was that all extruded terracotta is used where the cross section is concealed. You see the face of the terracotta, while we decided we wanted to explore exposing the cross section of the piece. And we started thinking about these sort of structures where you will be able to see underneath the terracotta and look at the cross section of it. And we were of course driven by some ideas also rooted in history of arches and highly ornamented spaces. And so these were our early studies, which started out as designing a cave, something that you would enter into. And then eventually we ended up, for various reasons, we ended up flipping it upside down and ended up designing something that was actually facing upward, that you witness from the outside. Interesting, and this was our early expression rendering that we did, which internally sort of bought it based on this rendering. They were like, yeah, this looks good. NBK were excited. And we started the process of investigating, how we were going to arrange this terracotta to do what we wanted it to do. And, it obviously, we knew that we had only one tile that we could make. It couldn't be multiple tiles, and we had to so find a way of tiling it. And we were also limited by the method of production. There are two ways that industrialized production of terracotta happens. There are two ways of firing it. One is the box kiln, which is the more sort of traditional way, which is to load up a room or a closed volume to stack material inside it, close it, and then turn on the fire, which usually is kind of time consuming because you have to put in time to stack everything, and then you close it, and then you turn it on. It takes 7 to 8 hours for it to reach the temperature. Then there's a hold time. Then you have to allow it to cool. Then you open it and you unload it. So one of the innovations that companies like NBK have done to architectural terracotta is that they have created these flat kilns. These are roller kilns where material enters from one side, and it's a very, very long kiln, about 700 meters or so. And the material moves through it, and it gets fired. So there is a kiln that is sort of very long, and you constantly feed material from one side and you take it out on the other side, and it's about 2.5 hour cycle, and the material comes out fired. So you never turn off this thing, never turn it on. It is constantly on, and you keep just feeding it with material. So but there are limitations of size that come from it. And so working with that, we were given this limitation, 400 millimeters by 100. So we tried to come up with a tile shape which had an interesting pattern in the cross section, which could then be tiled together to result in something that was at the same time very strong, but also very ornate. So you can see how as we were studying the tiling, we realized that we had ended up with a tile that could be combined in two different ways, a hexagonal arrangement or a rectangular arrangement, and both of them resulted in different type of visual patterns. And we also realized that to some extent, there were some real benefits to going with one versus another. So rectangular arrangement would give us a much finer effective resolution, but on the other hand, there was a inherent strength in hexagonal because it was made of triangles that we chose to move away from a rectangular arrangement so that we would end up with a much stronger structure. And so the whole question of resolution, because we had to live with it for strength reasons, we decided that we were going to try and overcome this through creating a complex surface at the cut level. So we said, what if we cut each tile 2 times to create a three-dimensional surface, a resulting three-dimensional surface? And we basically, all of this was happening through a three-dimensional parametric model, and we were able to resolve, we were able to overcome the question of resolution by writing this really complex script that would ensure that in the cut form, the tiles would seem that they were all matching and result in a two-dimensional geometry. And so, we were told, we knew that NBK basically had this one saw, which was a CNC saw, but it had very limited possibilities. It was not like a 5-axis saw; it was just a 2-axis saw. And so, working with that, we brought all of that into our model, and we'll talk a little bit about it. We started developing this idea of how we're going to hold it all together. And as the design evolved, it basically started looking something like this, where we were going to have these tiles that are held together by these hoops, these stainless steel rings. These are all 3D prints and prototyping that was happening in the office at the same time. And so with all of this knowledge, we were able to feed it all into an automated script where we were able to generate fabrication drawings straight out of Rhino for NBK, for the fabricators. And we had to really understand what kind of information they needed to be able to correctly register and align these pieces. And that sort of became a critical point of interaction between the two teams, the fabrication team and the architecture team. And so they were able to actually produce all of this. On the other hand, in Milan, the installation began, and we had to create this platform where the whole thing would stand. We had to distribute the load to not damage the paving underneath. This was an extremely heavy installation. But at the same time, we also needed a place, a way to transfer the geometry to the site. And this base became the vehicle for that. So we were able to do laser etching on the base where the whole thing will be built, and that would become the main geometric control for the entire structure. And so, the pieces arrived on site with individual sort of birth certificates so that you could identify which piece went where. And then the installation started, and we had lighting that was donated by a lighting company, which was incorporated in certain parts of it. And this thing basically kept on developing. And under 2 weeks, it was fully installed with a lot of hard work. And finally, this curved glass guardrail was put in. And this was sort of a small crew, but crew of masons, actually. These are all people who were used to working in brick, and they were doing this. And this was the resultant. And, it was very well received. We thought that we were successful in showcasing terracotta, extruded terracotta specifically, in a way that was somewhat surprising and extremely pleasant to the eye. And it had a we thought that it did a good job at finding ornament back in terracotta, even through the extrusion process. So this was, this was a great experience for us, because not only did we, in a very, very short amount of time, the entire thing from design to construction was less than 3 months. Everyone worked under a tremendous amount of pressure. And that was one of the reasons why we started out with this upside down as a cave, but ended up with it being, because there was these pieces, the way they were bundled together, there wasn't an inherent structural logic to them for it to be able to stand. So as we moved forward, the next opportunity that we got to work in such a research capacity, I'm sorry, so the next opportunity we got to work in this research capacity was in the architectural ceramics assemblies workshop organized by Boston Valley and Buffalo University in New York. And this time we set out to produce a truly structural tile in terracotta. So, at this point, it was really important for us that we were able to solve the problem of spanning space with just terracotta and no other material. So, with that in mind, we started looking at ways of using individual pieces to bridge across, to create spans. And we very quickly honed in on this idea of reciprocal beam action and reciprocal structures where you basically relied on interlocking pieces and then their inherent stiffness to maintain geometry. And this is a method that has been used many times in many applications in the past, where there is a stagger in the arrangement and that stagger enables a stiffness to develop. So using that idea, we started developing some ideas of a repetitive tile that would be able to interlock in a staggered manner and bring a lot of structural stiffness to it. And so, these are all early studies. We were trying to understand, it was a 3-dimensional tiling exercise, but it was also an exercise in finding a shape that could be produced in terracotta, which was another whole challenge. So, there is the idea of the 3D tiling, and then there is the idea of a shape that is visually appealing, but also producible. And so that was the journey of coming to a shape that, that fulfills all of these ideas. And we started, taking this forward. We 3D printed a lot of these shapes in-house, and then we started tiling them together. And we, as we did some of the studies, we realized that some things were not working out. Something was wrong, that at the edges, these terracotta tiles were flaring out. And we understood that, that basically the problem was that that the way we had shaped the tile that was easily pressable, we were trying to ram press the tile, that it was leaving, that it wasn't adequate, and that we had to change the tiles so that instead of just having an indent on the underside, it would actually have a hole. And that hole kind of was a little difficult to do in a ram press, which is how we were looking at this tile to be made. But we knew once we changed that design of the tile, we knew that suddenly we had solved the problem, and it was extremely strong and really working well together as a tile. And so this is the vision that developed for an overall arch or a vault. And then we are also looking at glazes and gradient glazes, etc. So you'll see some of this at the end. So this was the method of production that we originally started out imagining. And this is a very, very old method of production. You basically have a negative and a positive mold. You put terracotta in between, you press it down, and you pull it back up, and you have shaped the material. And this method has been used in architecture. This is the Ringling Museum by, I think, Payette in Machado Silvetti, which was in Florida, which used such a metal to make these 3-dimensional tiles. So we knew what such methods could do, and we were working with that. But once we had to change the shape of the tile to have that hole underneath, we were taken to, we had to reimagine the method of production. And interestingly, Boston Valley decided to bring into the picture something called pressure casting, which is a method that is commonly used in the world of sanitary ware. All the ceramic sanitary fixtures are cast in this manner, but in architecture, it is relatively unusual to cast materials like this. But that became the method that Boston Valley could do. Interestingly, they could do it in-house. They hadn't done a lot of it, but so we started then working with them with that method in mind. We started developing the tile. What this shows is basically two positives, the way they would produce the mold. And then they set working from there. They did a 3D print in foam first, and then that was used to create a positive. This is actually not a wood, but an MDF positive. And you can start seeing the beginnings of the mold process here. On the right-hand side here is the pressure casting machine, where it is sort of like injection molding for terracotta. And this is a fresh green piece out of the mold, which is then taped up, masked for glaze application, and then fired in a box kiln, resulting in a tile that looks like that. And it was an extremely beautiful piece of terracotta, very heavy, but it inherently, it was a fulfillment of a lot of hard work that we had done over maybe 5 months. And interesting. And so we had these little bits of silicone tape that we were putting to prevent any damage. And then it was ready to be interlocked and assembled. So we had also designed this. So, this Boston Valley through this program would allow us a limited amount of pieces. So we couldn't do the whole arch. We just did a small piece of thing. So because we couldn't complete the semicircle, this was going to be a cantilevered piece. So we had to come up with a hefty base design that would provide the reaction to create a cantilever with such heavy tiles. And so this is sort of the base that we designed, which had pretty interesting, complex 3D printed components to it, as well as laser cut plywood components and steel rod and all of that. And that sort of opened up the process of starting to interlock it. And it was amazing how well each of these tiles slid into each other. And we were able to achieve basically exactly what we had set out to achieve. So this is sort of the final look of it. This is a 3D printed model of the whole thing if we were to get to build it. And someday maybe we do it in terracotta, but I am right now interested in exploring this concept, but in stone, exploring this concept in cast glass, and trying to find how the shape of the tile changes as you change material, when you change methods of fabrication, and you change the weight of the material and its properties. So that's kind of really interesting. And that is it.
Thank you, Samir. Yeah, I jump on very quickly. So, first of all, I'm so glad to bring you here to the table to show the work that you do. Is so specific, and it would be great if you're able to help so many architects that are trying to achieve unique structures, and you are specializing in facades in a way that is so unique. I've seen other facade consultants that are bringing to the table just whatever is done to in the field or in the market, and you just need to choose from something already done to this that is completely experimental, and giving your experience something new could be completed in a fast way, because you already have the experience with the materials, with the technology, with the availability, And when we have to look at facade of buildings, we need to see timings too. So if you're aware of what is available, how long it would take to be produced, and all those aspects that are essential at the time that you're doing design development. Actually,
Absolutely.
you need to know what material you're going to use on your facade, and you usually have a schedule for when the project needs to be completed. So
Absolutely.
having someone with your experience is fantastic. Vivian, do you have questions from the public?
There is one question here. Is a terracotta facade a rain screen or open? If you can elaborate more.
It is, and it typically is a rain screen facade with open joints, and the performative weather enclosure sits behind the layer of terracotta. That is correct. And just to go back to what Natalia was commenting on, you're exactly right. As we deal with complexity and we deal with these materials and the performative side of facades, and as we go further and we start talking about carbon, and we start talking about how we as a design community are going to respond to this climate crisis, I feel the question of strategy or strategic thinking about projects becomes really key. And one of the things that I really want to do through Techne is bring this approach of strategic and systemic thinking to the process of design of facades, so that we are not at the very early stages when we are starting out creating an architectural vision. We also create a vision of success, a trajectory of success for a project, by incorporating not only the design aspiration, the performance aspiration, but also the other givens of a project, like its geographical location, the nature of industry over there, clients' cost constraints, or the issue of carbon and the issue of sustainability. So all of this must start to get dialed into an overall vision of success for a project, and that sets the schedule, that sets the sequence of material verification and approval and testing and all of that. So you're right on.
So, and just thinking about facade, we saw one facade here in New York City, one of the tallest building, and the fact that it's made with terracotta and not with metal. What benefit do you see on terracotta facade? I personally love it, but just tell us the benefit.
So one of the important, so there are a few ways of approaching this question, right? So the most important is that we are going to see, as our buildings are required by regulation, by changing codes to become more and more efficient, and as our facades are being required to become more and more efficient, I think we are going to see that less and less, fewer and fewer buildings are going to have all glass facades, right? And we will have to incorporate more diversity of materials on our facade in order to achieve a lower window to wall ratio, right? Because those days where you can have massive buildings with only glass all over them are likely gone. And as we develop this appetite to have more opaque material on our facades, we are going to rely heavily on a handful of materials that actually are reliably durable for long durations, right? Because the materials that are used on the exterior, especially on the facades, have to, they have this really a unique requirement to be able to withstand wind and weather for 50, 100 years under full exposure to ultraviolet light and to full exposure of rain and acid rain and pollution, and be able to be cleaned and everything. And because of that, the palette of materials for exterior application is an extremely small palette. compared to the materials available for interior. Of those materials, of course, glass stands apart because glass, is extremely resilient. It does not get affected by UV light or by pollution or anything, which is why it is such a popular material. But amongst the opaque materials, that burnt earth, cooked earth, is one of the most long-lasting materials. We know that because every archaeological excavation that happens, and when we discover artifacts from thousands of years ago from human civilization, they're all mostly terracotta pieces, right? They're all mostly ceramic and terracotta, because once you take earth and you cook it, it becomes completely indestructible. It is inherently super durable. And therefore, terracotta and ceramics is very similar to glass. Glass is cooked sand, it's molten sand made into glass. Terracotta is cooked to a lesser temperature than glass is, but it brings the same kind of durability. So there is an inherent benefit in using that material because it is just completely durable. Of course, there is the question of carbon and terracotta, because you have to fire it to produce it, which is also true for glass, which is true for most metals. The challenge is going to be to transform the production enough to reduce its carbon footprint. Right now, the way terracotta, especially the industrial production of terracotta, happens, it is right now a little heavier on carbon. And what doesn't help is terracotta is also very heavy in weight. So that sort of, if you were to take a unit global warming potential of terracotta, because you're using such heavy material, you end up with a big number. So right now, that particular measure, that metric, is not in favor of terracotta, but I am confident that the industry will change that.
And this is a more technical question, but is there any particular thickness of the terracotta to withstand this? Because this is one of the tallest buildings in New York that we're talking about. Like, as you said, weight is a big factor on this. Is there a magic number for thickness?
There is, of course. Usually all terracotta, extruded terracotta, the walls are between 8 and 10 millimeters thick, so about 3/8 of an inch thick, and that really comes from the science of firing it. So inherently, so you cannot make it super thin because of the resulting warpage that could occur when you fire terracotta, because anything that sort of starts out wet and liquidy and becomes harder and then gets fired, it's going to have a lot of shrinkage in it, and the shrinkage can cause a lot of breakage and risk. So there is obviously, it is in the world of material science and chemistry that how they come up with this thickness. It is also to do with fluid dynamics, because you're extruding it, so you're pushing this material through a die, and so something that will hold its shape. So there are a lot of technical things that come at it, but the resulting terracotta material is extremely strong in certain ways. So it is not good in tension, but in compression or in shear, it is really strong, which allows, when we put it on this tower, 1,400 feet, each tile of terracotta is individually supported. So it's not carrying any load other than its own. But the wind load is not even close to the capacity of the strength of terracotta. Like, the wind load is very small, even though it's a very high wind load that high up. But terracotta is far stronger than what the wind load can affect.
I think that when we talked about terracotta in developing countries, where I'm coming from, Argentina, we saw a lot of guys just glued there to the facade, then they fall down. Yes. And it's like a hazard, like someone, can die with
yes.
in their head. So, as we could see in your slideshow, there is a specific way to make this connection. It's all, did you use a stainless steel? What type of connections you do to the structure?
Right. So we basically have to combine a ductile material like metal. It could be aluminum, it could be stainless steel. We typically stay away from steel so that we don't have to deal with rusting and resulting loss of strength or staining. So we stay with stainless steel or aluminum, but we have to integrate that into the terracotta assembly as a redundancy, so that if there were to be a breakage, large pieces of terracotta could not disengage from the building and fall. So, in both the tall towers that you saw, one of them had those aluminum extrusions that were embedded in the terracotta that would basically act as a safety device. And in the Detroit project, there are actually stainless steel cables that thread across all the terracotta pieces on one unit, which also perform the same function. And that is just good practice and safe design. The way terracotta pieces are supported, they're all supported through dry connection, right? So what you're talking about, where there is a wet set terracotta like masonry, where you take mortar and you just glue the terracotta, that used to be done in New York also in olden times. And there was a lot of problem with pieces falling off the facade, which is why we have all the scaffoldings all around New York City, and you have local law 11 and the need to keep maintaining your facades. But the way we use terracotta now is very different. And we ensure not only that all the terracotta is held through positive connections using metal, but we also allow for a lot of expansion and contraction of terracotta freely, so that there are no, when the temperature changes and the terracotta shrinks or expands, which will obviously happen at a different rate than the aluminum frame that it is mounted on. There are no residual stresses, or there's no stress concentrations that happen inside terracotta that will force it to disengage or break, right? So there is a lot of science in understanding the behavior of terracotta vis-a-vis its supporting material as temperatures change and as humidity changes. And so, yes, this is something that is incorporated very, very, very carefully in the design of these structures.
Well, it's such a beautiful material of itself. So many things are done in terracotta that are, artistic, and why not seeing as you show the facade of this building, how with these intricate shapes and movement that makes it so beautiful by just each piece of itself. And I don't know, Vivian or JJ, do you have any other questions for Samir?
I don't see any additional questions. Thank you.
And JJ, I see you there.
It's overwhelming. It's beautiful process and structure, integrity that put it into the old, ancient materials. But I think they're also fabulous to see. I believe that building is incorporated with the situation of the historical, the small building, right?
Yes.
So that inspiration that came from original architectural concept, I think that was very amazing. And then they can actually, that dream to be a real, to using all the technology in cooperation with the variety of countries. I happen to, being in the presentation of original design concept process and how they twisted each of those pieces, and to be able to connect, you literally have to put out numbers, thousands of a different number that you have to be right that corner and
absolutely
and right that height. So I hats off, especially your specialty of the facade. We need some super focused, specialized, technology to be able to have, conceptual architects that who can dream too. So
Yes.
these are the things with this New York City architecture biennial this year, obviously, collaboration of every piece of, you can imagine, it's almost 1,000 disciplines to be able to connect, start to end, and labors and deliveries and all,
Absolutely.
Yeah,
Absolutely.
so I am, more than statement and, just really not a comment. It's just wonderful to hear that small pieces you have developed it in the Milan. I just loved it, everything.
Thank you so much. Thank you very much.
Yeah.
Yeah, I really appreciate your comment. I think it is true that, the act of creating an idea, which is of course sort of central to our role as designers, and then converting it into a material form and a material expression,
Exactly.
that process is where the challenge of architecture is, right? That is where where architecture comes to be, because
Right.
if it was not materialized, then it will remain an idea. It cannot become architecture, and it is
That's
just
correct.
through the process of materialization.
Yes.
And for me, the most exciting part is that while idea generation is an internal process, and one could say that it is a process of self-reflection and maybe individual genius, but the process of materialization is very much a collaborative process.
Right.
And every discipline and every field that involves themselves enriches that process by bringing layers and layers of
Yes.
new knowledge and information. And
Correct.
so some of us who have the benefit of being a part of the process from early design till construction, we are able to learn from and enrich our own selves, our own minds, with the layers and layers of thinking that needs to put into it. And so that is in crux the passion of my life, right? That
That's
is, and
right.
probably yours too, because you
That's
acknowledge
right.
and you recognize it.
That's exactly right. Architecture is something that challenging me
Yes,
in a
exactly.
whole life, and it's a dream to the inception to the delivery. I mean, you have so many layers. The more the layers, I think somewhat the more mature feeling,
Yes.
and that art and the result is just amazing. But it is something about the, as you mentioned the earlier the presentation, architect, tech, and technique. So this is all connected, art and
Absolutely.
technology, and then that tech developed to be a delivered, and then it get to the bottom line, and just
Absolutely.
love of our our career and
Yes,
occupation.
yeah, I would just sort of like to say one thing at the very end, that, we are talking about the material practice of architecture, right? We're talking about the practice of architecture that deals with the materialization of ideas. And I want to say that, the challenges that we face today, especially climate crisis, especially, the immediate surrounding, even the challenges coming from the pandemic and the supply chain, and
100%. Yeah.
all of these challenges are actually directly related to the material practice of architecture, right? So
100%.
while we all understand and acknowledge that there are many determinants of architecture, including economic forces and political forces and emotional forces and all of that, but it is the material practice of architecture that must find answers to our immediate challenges. And
Yes.
we as architects will only find success dealing with climate change and carbon by engaging with materials, by engaging with supply chains, by engaging with process of fabrication. And I think that the time is high for all of us architects to say and embrace that the material practice of architecture is really important to our practice if we want to save our planet, if we want to solve the problems that are ahead of us.
Well said and done.
Thank you.
Thank you very much.
Thank you. Thank you.
Love it.
This has been a pleasure. Natalia, thank you for this opportunity, and I am so happy to be here.
Yes, thank you so much. You know, I think we have to give the floor to the next speaker. But before that, you mentioned one thing, tools. What programs do you use in regular basis to create this facade, to test, try? You mentioned Rhino throughout your lecture, but which programs are mostly used?
There is a whole host of programs. So, of course, for 3D visualization, parametric modeling, Rhino and Revit are sort of both used. There is a set of programs that are used for technical verification and analysis, predictive analysis. So it could be structural design tools like STAAD or glass, specifically glass design tools. There are thermal analysis tools like Therm and Optics and Window. There are also tools like Radiance that would help you do daylight analysis and glare analysis. There are a host of environmental analysis tools for whole building energy modeling that that also have an impact on facade design. So eQuest or ComCheck, etc., are applicable to facade design. And then, in terms of design technology, I very much like to work in virtual reality, and we will be employing virtual reality, Unity, etc., to visualize and help in the design process of facades. I really like to employ 3D printing for rapid prototyping to understand detailing. So at Techne, we are trying to bring all of these new design technologies to the world of facade design and consulting, which somehow has remained aloof from these new technologies. And then, of course, there is the whole host of management software. I'll not go into that, but yeah, it is a wide variety of software.
Great. Well, thank you so much, and well, pleasure to have you. And now, yes, I'll let you go.
Thank you so much.
Thank you, JJ, too. Thank you.
Thank you, everyone.
Bye-bye.
Thank you so much.